Good morning. We move on to the second example on simply supported beam. Here we have combination of loads, point load as well as uniformly distributed load. So a beam AB, the distances are, this is 2 meter, this is 4 meter, this is 4 meter, and the points also I will mark, say it will be C, this point is D. So there are 2 point loads as well as a uniformly distributed load. So always the first step in simply supported beams is computation of support reaction. So let us find RA and RB. We'll move quick. What is RA plus RB? The total RA plus RB. Say this is RA. This is RB. Total load acting downwards is 50 plus 10 into 4 uniformly distributed load. So 10 into 4 plus the load is 40. So it is 50 plus 40, 90 plus 40, 130. So this totally it is equal to 130. That is the first equation. RA plus RB is equal to 130. Now take moment about B. Taking moment about B. RA. This RA produces clockwise moment. RA into 2 plus 4, 6 plus 4, 10 is the span. RA into 6. RA into 6 produces clockwise moment minus downward load 50 into distance 4 plus 4, 8 minus this much load 10 into 4. This 10 into 4 is the total load, that is 40. This total load is assumed to be acting at the center of this. So this total load of 40, this distance is 2, this distance is 4. It is 2 plus 4. The load 10 into 4, 40 kilonewton acting at 2 meter from here. So from here to here the distance, this is 2 and therefore 2 plus 4 is 6. Then 40 kilonewton load minus 40 acting at 4. So that is a total reaction. RA into 10 minus 50 into 8 minus 10 into 4, that is equal to 0. Taking moment about B and equate it to 0. From that we get RA 80 kilonewton. So we get this value 80 kilonewton, this RA. Therefore RB is equal to 130 minus RA, which is equal to 50 kilonewton. So we have got both the reactions. RA is 80 kilonewton and this RB is equal to 50 kilonewton. So that is the first step. Now the second step is shear force calculation. Step 2, shear force. You can easily write the steps. First, we consider, in this case, we are always going to consider left of section. For our sign convention for shear forces, if you consider a section, left of section, upward loads are positive. Left of section, upward loads are positive. So shear force at A, first point is A. That is, if you consider a section in this line, in this portion AC, consider left of it. Shear force at A is 80 kilonewton positive, since it is up. At the point C, there is a point load is acting, so you have to consider just to the left as well as right. FC at C, you have to consider FC left. Just to the left of C, there is only 80 kilonewton. When you just move to the right of it, it will be 80 minus 50. 50 is acting downwards. Upward is positive. So 50 minus, it will be 30. So at that point C, there is 80 kilonewton. From there it suddenly drops to 30 kilonewton. Then coming to point D, at D also there is a point load. So we have to consider FD left. FD left is just to the left of D. 80 acting upward, 50 acting downward. This 10 into 4, 40 acting downward, 10 into 4. So it will be 80 minus 50 minus 40. It works out to minus 10. Just to the right of D, this minus 10, because I have to come from here, minus 80, minus 50, minus 40, minus 40. So minus 10, minus 40. When you move to the right of D, when you come here, all the forces to the right of it. So it will be minus 10, minus 40, it will be minus 50. So when you come to FB, shear force at B is minus 50, the same value. See, the reaction is 50. So if you compute the reactions from the shear force from one end to the other, you will arrive at the support reaction there. To draw the diagram, draw the baseline. Draw the baseline. Draw the baseline. Mark the values. FA. FA is 80. So this is 80. From here you mark 80 Newton. You mark 80 to some scale. 80 kilonewton. Then at the point C, FC left 80. So this is also 80. FC right 30. So here from here you mark 30. Mark the point at 30. Connect it. From baseline you mark 30, connect it. FD left minus 10. FD left. FC right is 30. FC right 30 we have marked. Then FD left is, this is FD left is, okay, minus 10. So at this point you have to mark minus below the line 10. Since there is uniformly distributed load, connect this 30 and 10 by a straight line like this. Since there is UDL, connect 30 and 10 by a straight line. FD right is minus 50. So at this particular point, from here you mark 50 Newton downward. Mark point 50. Connect it. FD right is minus 50. That we have marked. FB is minus 50. So here also 50. So this is the shear force diagram. You can see 80. From here you have marked 80 upwards. Then there is no load, both straight. Then there is 50 acting down. So from that 80 you move down by 50 units. So you come to 30. Then minus 40. From 30 you come down by 40 units. So that you will come to minus 40. There is another 40 kilonewton vertically down. So from 10 you come down by 40. So this net ordinate is 40. It is 50 minus 50. Then go straight since there is no load here. Then go up by 50. From here you go up by 50. This reaction. So you come to the baseline. You start from the baseline. 80, no load. Come down by 50. So this is 50. So you reach the value by 30. 30 minus this total load 40. Will reach minus 10. Connect it with straight line. At this particular point again come down by 40 units. So this is 40 units. This unit is 40. There is no go straight. There is upward 50. So you reach that. This is positive. This is negative. Now the speciality about this is, in this portion since there is UDL, there is this shear force diagram, there is a point where the shear force is 0. This point is very important. It will be at a distance x from C. This point is C. This point is D. In the portion CD, there is a point where the shear force changes its sign or the shear force becomes 0. At that point, the bending moment is going to be the maximum value. Okay. So the point of maximum bending moment is of interest to civil engineers. So the point C, this point on the portion CD where the bending moment is, the shear force is 0, we have to locate. Now I will write that to find the location of zero shear force. So next we have to find out the point where the shear force is 0. So to locate point where shear force is 0. See the diagram, it is a linear diagram. Let it be at x from C. I marked that x. That point is at x distance from C. Let me mark it as E. So we have got all A, B, C, D. So I mark it as E. From this similar triangles, this triangle, this is 30 units. And this triangle, this is 10. This is 10 units. Okay. This is 10 unit. And this is 30 units. It's marked here. This is 10, 30 and this is 10. So I can write 30 divided by x. This 30 divided by x is equal to this 10 divided by this distance is 4 minus x. Isn't it? This distance is 4 minus x. This is totally 4. So this is 4 minus x. 10 divided by 4 minus x. So cross multiply. 30 into 4. 120 minus 30x is equal to 10x. From that we will get x is equal to 3 meter. X is equal to 3 meter from C. That is the point of zero shear force is 2 meter from 3 meter from this point C. So it is at this distance from the left support. It is at 5 meter. So you have to write, always mention the distance from A at 5 meter. So the point of zero shear force is at 5 meters from left support. This will be useful in the next step of bending moment calculation. So this is the point where the shear force is 0. From similar triangles we have done it. Now we will be doing the calculations for bending moment. So the next step, we are going to calculate the bending moment. You know the bending moment at the support A. Bending moment at A is 0. Always write that is here. MA is equal to 0 and MB is equal to 0. Bending moment at the simple support ends will be always 0. Now let's start. Sign convention for bending moment is, if you consider a section, left of the section clockwise moment positive. If it is right, anti-clockwise positive. So left of the section clockwise moment positive. So MA 0. The next point is C. So consider left of C, the only load is 80. 80 into 2. This is acting like this about C to produce us clockwise moment. So moment at C is equal to RA into 2, which is 160 kilonewton meter. Positive because place your thumb like this, rotate it about C. So it produces clockwise moment. So clockwise is positive. Now next point is MD. MD, if you consider left, first load is 80. What is the distance? 2 plus 4, 6 meter. 80 into 6. Then this 50, this vertical load 50 is producing anti-clockwise moment. 50 into 4 minus 50 into 4 minus this UDL. This UDL total value is 10 into 4, that is 40. UDL 10 into 4 is a numerical value. It is acting at a distance of 2 meters. So this 40 into 2. This is the total moment at D. If you compute it, it will work out to 200 kilonewton meter. For those who can understand, another easy way is when there are large span and several loads, it is not necessary that you always come from the left. You can also come from the right and see it. See, if you treat this point D from the, take a section at this particular point, and from here if you take it 50 into 4, the moment at D can also be written as 50 into 4. What is the moment? It produces anti-clockwise. So right of section anti-clockwise, that is also positive. So I can also write, if you can understand, you use it, otherwise we can stop at this stage. Those who can follow this, you follow this. MD can also be written as RB into 4. That is also equal to 50 into 4, 200. This is easy way. From the right end, if you say there is only one load, if you want to take moment about D, if you consider start from this end, there is only one load acting at 4 meter. So it is reaction RB into 4. Use your thumb, place your thumb like this, take moment about this, it is anti-clockwise. So right of D, if you consider anti-clockwise moment positive. So both these results are same. Now we have got all the bending moment values. Let us plot the diagram. You draw the baseline. Extend it. Draw the baseline. At this point the moment is 0. Here also the moment is 0. Moment at C is 160. So here the moment is, from here you mark 160. You mark 160. MD 200. From here you mark 200. This is 200. So this portion you can connect it with straight line. Here also you can connect it with straight line. And this portion, this 160 and 200 has to be connected with a parabola, because there is uniformly distributed load in this portion CD. So this is point C, this is point D. We have to connect these two by a parabola in such a manner that this point where the shear force is 0, the bending moment is going to be the maximum. So you connect it in such a manner that this point is going to have the maximum bending moment ordinate. So this is 160, this is 200, and this portion you have to connect it with, this is point C, this is point D, you connect it with a parabola. Connect these 2 points with a parabola and see that the maximum ordinate is at this point where the shear force is 0. So next point is, so this is straight line. This is actually straight line. My drawing is very poor. This is straight line. This is also straight line. Next aim is find maximum bending moment. M max. Bending moment is maximum where shear force is 0. So here that is at 5 meter from left support A. So the bending moment is maximum value at 5 meter from the left support. So let us find out the bending moment at 5 meter from here. Consider left of that section. Consider left. What are the forces? RA acting at 5 meter. So it is RA into 5. At 5 meter from here, RA into 5. So it will be somewhere here, isn't it? 5 meter from here. RA into 5. Then this load. Minus 50 into, that's distance. 5 minus 2. It is 3 meter. 50 is acting at 3 meters. Then minus 10 into for this 3 meter length. 10 into 3 is the load. This is 3 meter. I marked this. This is 2, it has to come somewhere here. 3 meter means somewhere here. So 10 into 3, this much is 3 into 3 by 2. 10 into 3 into 3 by 2. So repeat once again. You consider a section at a 5 meter from left end. At 5 meter from left end, RA 80 into 5 minus 50 into this 3. 10 into 3 into 3 by 2. So it works out to RA is 80. 80 into 5 minus 50 into 3 minus 10 into 3 into 3 by 2 will work out to be 205. This gives the answer 205 kilonewton meter. 205 kilonewton meter. So this maximum value Mmax is 205 kilonewton meter. This ordinate is from here you mark 205. Then you hash the inside. You hash the inside of the diagram. Write positive. This is the bending moment diagram. So with that we complete the simply supported beam, the most general case of loading, UDL plus point load. Thank you. Next video I will be explaining simply supported beam with couple or moment. Thank you.